All right, let's look at number 1, and they want to know which set of probabilities is legitimate. So remember, probabilities always goes between 0 and 1, so that means you can't be over 1 and you can't be negative. And the only one that meets that criteria here is A, because 4 plus 4 plus 2 is 1. Okay, let's look at 2, and it says given events A and event B, and then they tell us A or B is 0.68, then the two events are. All right, so let's go do this math. And so we know that the probability of A or B is equal to the probability of A plus the probability of B minus the probability of A and B. And that's what we have to find out, because that A and B is so important. That tells us whether they're mutually exclusive or if they are independent. Okay, so A or B is 6.8. It's equal to 0.45 plus 0.25 minus x. So 0.68 is equal to, gee, I'm getting tired here, 0.45, 25, I need my calculator. 45 plus 25 is 0.7 minus x. So, 0.68 So that means that the probability of A and B is equal to 0.02. Okay, now, since 0.02 is not 0, we know they're not mutually exclusive. So, mutually exclusive and independent, it can't be that. Neither mutually exclusive, not enough information. Mutually exclusive but not independent. Okay, independent, it can't be that. All right, so how do I test for independence? Well, I have to see if the probability of A times the probability B equals the probability of A and B. So I'm going to get on my calculator 0.45 times 0.25, and that is equal to 0.1125, which doesn't equal to 0.02. So they are not independent. So they're not independent, and so they're neither, so the answer is D. Okay, let's look here at 3. They say a jello bean is chosen at random. What is the probability that it is pink? So all of these here should add up to 1. So 0.3 plus 0.2 is 0.5, plus 0.2 is 0.7, plus 0.2 and 0.1, so pink is 0. A pink jelly bean here. So what do I need? Isn't that right? 1, 2, 3, 6, 7, 10. These all add up to 1. So it's E. All right. Okay, a die is to be tossed 5 times. The first 4 tosses land even. What is the probability that is even on the 5th one? All right, so the question is really here is rolling a die independent or dependent? Remember, dependent means that the prior results will affect the next one. Independent means that every time has a fresh start. So I'm hoping you realize it doesn't matter how many times you roll a die or toss a coin. Doesn't matter. That the probability remains the same on the next deal. So, okay, so we're tossing a coin or rolling. When I say tossing of the die, yeah, I got that bad, didn't I? Okay, so the deal here is we're rolling a die. And so every time the probability of getting an even is still the same. It's still 1/2. So the answer is B. And it's 1/2 because there's 3 out of 6. Okay, 5. Which of the following statement is true for 2 events, each with a probability of greater of 1? All right, so let's talk about this. You need to know about mutually exclusive and independent. The probability of A and B is equal to 0, then they are mutually exclusive. Or you can say they're disjoint. All right, now remember, if they're independent, then we can say that the probability of A or B is equal to the probability of A times the probability of B. Okay, for this one, you need to know your algebra. You need to understand that the only way you can get 0 when you multiply two numbers together is that one of the numbers has to be 0. There's no other way to get 0. So that means that in order for the probability of A and B to be 0, the probability of A or the probability B has to be 0. But what do they say here? That is greater than 0. So it is impossible for two events to be both mutually exclusive and independent. They're either one or the other. So look at what A says. If they're mutually exclusive, then they must be independent. No, that is not true. If the events are independent, they must be mutually exclusive. That is not true. If the events are not mutually exclusive, they must be independent. That is not true. If the events are not independent, they must be mutually exclusive. That is not true. If the events are mutually exclusive, they cannot be independent. So the answer is 5E. You need to understand this stuff. Okay, let's go to this one. I picked this problem here. It has the same topic. All right, they say these three events are mutually exclusive. So if they're mutually exclusive, the probability of A and B is equal to 0. A and B is equal to 0. The probability of A and C is equal to 0. The probability of B and C is equal to 0. They're all equal to 0. Remember now, if they're equal to 0, then they can't be independent. They cannot be independent. So that guy is out. 2 is a winner. Okay, what do we know here? The probability of B or C is equal to the probability of B plus the probability of C minus the probability of B and C. But that is 0, so yes, 3 is true. So the answer is 2 and 3, so the answer is D. Okay, let's talk about this. If any one of these fail, then everything is off. So the only way that it works if all these things passes, well, that would be 0.99. Second one would be 0.97. Third one, 0.96. You multiply those three numbers together and you get D. Okay, 8. This is a Venn diagram. Now, you can tell you have a Venn diagram if you have two things going on. And they talk about the two things happening together, or they talk about neither of the two things happening together. All right, so let's go set this up. Let me erase what I have here because I need the space. All right, so I got a different color here. So here is my region. Now, we're talking about percent, so my universe is 100%. Okay, I can't put they won't let me put the percent sign there. All right, so these are the percent of the people, oh, I can't even pronounce that word, psychiatry class, and then I got 28 people in a foreign language class. So this is 17, and this is 32, 28. All right, and then they say 32% are enrolled in either a psychiatry class, foreign language, or both. So that means one of these three regions, region 1, region 2, region 3, they have to add up 32. Well, I have 17 and I have 28. So 17 and 28 is 5 is 45. Subtract 32 and I get 13. So in this middle, which I didn't leave enough space, is 13. Okay, well, for the psychiatry, or whatever it's pronounced, if 13 is already accounted for and there's 17, so that means 4 goes here. And here for the foreign language, if there's total 28 and 13's here, then I have 15. All right, so what is the probability a student chosen at random will be in both classes? Well, that's just 13%, so the answer is D. I guess I did too much work there, huh? Okay, so what they want to know is what is the probability that they are the same color? So we're picking 2 candies. So that could be a brown and a brown, which is 0.3 times 0.3. Or a red and a red. So if I said that, it's going to be plus 0.2 times 0.2. Or a yellow, so I plus 0.2 times 0.2. Or a green, plus 0.2 times 0.2. Or an orange, plus 0.1 times 0.1. Okay, so this is going to be 0.3 squared plus 0.2 squared, that's for the red, plus 0.2 squared for the yellow, plus 0.2 squared for the green, plus 0.1 squared for the orange. And you add them all up and I get 0.22. So the answer is B. All right, so reading this, I'm hoping you're saying to yourself, oh, this is a tree problem. So either we have icy weather or we don't have icy weather. I say it's a 30% chance of a flight being delayed because of icy weather. So if this is 0.3, this is 0.7. If a flight is delayed because of icy weather, there is a 10% chance the flight would be the delay of mechanical problems. So we also have mechanical problems, or we don't have mechanical problems. So this is 0.1, this is 0.9. Okay, if a flight is not delayed because of icy weather, there's a 5% chance of mechanical problems. So here's mechanical problems, 0.05, and mechanical problems, 0.95. Okay, so if a flight is selected at random, what is the probability the flight will be selected will have at least one of the 2 types of delays? Okay, so are we delayed because of icy weather and because of mechanical problems? That's at least one of the 2 types, isn't it? So that's a winner. Here is icy problems and no mechanicals, but still an icy problem. Here's not icy, but mechanical. That's one of the 2 delays. And here's icy and no icy and no mechanical. So what I'm going to do is I'm going to multiply those 2 together and subtract that from 1. So 0.7 times 0.95. I like this problem. So I get 0.665. So 1 minus that, and I get 0.335. 335. The answer is B. All those multiple guess questions have been on other exams. You need to know how to do those.